Okay, in this question you have over here you have a quadratic function. Okay, if you have a quadratic function, you have only one turning point. Okay, now when you dA dx, you have only one x value when dA dx go to 0. Why there's only one value of x? Because there's only one turning point. When you say dA dx, basically you're talking about the turning point gradient. Okay, the gradient is equal to 0 at the turning point. So at the turning point, there's only one value of x when the turning point equal to 0. In other words, there's only one turning point. Okay, and that happens when x goes to 3. But the normal way to prove that, we have to go further and do d2a dx squared. Okay, so when you differentiate this dA dx, you got a negative value. When you have a negative value, okay, you have a negative value, it means you have a, like over here you can see, negative value have a maximum point. Therefore you can conclude that when x equal to 3, a, the y function in this case is a, it is at its maximum value. Okay, simple as that. Because there's one turning point, when you d2a dx squared, you have a known value, whether it's positive or negative. Okay, let's look at this example of cubic equation. The cubic function have actually two turning points. Okay, now let's find what the x value of the turning point. So you dA dx, okay, you get this, and you dA dx go to 0. That means at the turning point the gradient is 0, and you put that into the dA dx equation, and from there you found x equal to -2 or 3. Okay, as I say here, for a cubic equation, there's two turning points. From this answer here, you know, there's two turning points, one at x equal to -2 and the other one at x equal to 3. But in this case, how do you know whether which one will give a maximum point, which one will give a minimum point? Okay, now the way to do it very easily would be to go ahead and find d2a dx squared, which gives you 2x minus 1 when you differentiate the function dA dx. Okay, now over here d2a dx squared, x is x does exist in this d2a dx squared. Okay, the main reason why this x exists is for you to substitute the x value here. X go to -2 and x go to 3. So if you take x equal to -2, you notice that d2a dx squared is equal to -5, which gives you a negative value. So in other words, when x equal to -2, when you have a negative value, then it is at the maximum point. Okay, then when you substitute x equal to 3 here, your d2a dx squared actually become positive. Okay, that means to say when x equal to 3, the function, the original function here, it is at its minimum point. How do you find the value of a when x equal to -2 or when x equal to 3? Very simple, just take this value, substitute into the original equation, then you find the maximum area. If you put x equal to -2 or you put x equal to 3, then you will have a maximum minimum a value if you put x equal to 3. If you want to sketch this graph, it's basically in this manner. And then when x equal to -2, x equal to 3, you will sketch it. It will be this manner. Okay, so at this point, it's the maximum turning point when x equal to -2. When x equal to 3, this will be your minimum point at this point here, when x equal to 3. So this will be the a function. Okay, we will plot this a, this x. That's it.